Good morning, one and all. I am Muttaselvi, Assistant Professor, Computer Science Department. I'm going to explain you about the flip-flops from Digital Electronics subject. It's an electronic subject which is mandatory to the computers. Here we are going to see the minute cells of that electronic parts, right? Here, the first topic is flip-flops. The concept of flip-flop. Flip-flop is a two-state device. We can call it as a multi-vibrator also. So here multi-vibrators, it's a important part like a switch in a switchboard, right? Here in multi-vibrator, we are having monostable multi-vibrator, bistable multi-vibrator, and astable multi-vibrator. Totally three types of multi-vibrators. In monostable multivibrator, it's a one short circuited S. It can give a pulse from the source only once. In a bistable multivibrator, it can use the memory devices for sequential logic. At the same time, it can set and reset. Two logics will be there. One is set logic, another one is reset. That is why it is called as bistable multivibrator. So monostable multivibrator as well as bistable multivibrator, the difference is single time pulse source will be there, double time pulse source will be there. One is for set, another one is for reset. So bistable multivibrator is known as flip flops. Another one astable multivibrator, that is nothing but oscillator. Oscillator is one of the circuitry in digital electronics. We'll come to the part of flip-flops. So initially I said it is a bistable multivibrator circuit. It is called as latch. Latch is a temporary storage device. It's a basic form of memory. So initially we have four flip-flops. We are going to study about SR, JK, D flip-flop and T flip-flop. SR flip-flop is nothing but set and reset flip-flop. It can be constructed using NOR gate as well as NAND gates. NOR gates, in NOR gates, it produces always high input, high input or responded to the NOR gate. But in NAND gate, active low inputs are responded to the NAND gate. The meaning is what? Active low input means 0. Active high input means 1. So for that case only it changes. So whatever the gate we are using, accordingly we need to change the truth table too. Here as per this picture we are using NOR gates. So the previously what I said, NOR gate means both the input should be high, right? High. Any one of the input should be high. It gives this set and reset. Otherwise, if both are low, it is going to show that it is a previous stage. If S equal to 0, R is equal to 1, then it is reset state. S equal to 1 and R is equal to 0, then it is set state. Then both are 1, yes, or both are 1, then there is a problem in the state. What is the meaning of this? Invalid, right? Otherwise, we can call it as forbidden state. So that is the logic diagram has been given in SR latch. This is the SR latch which is constructed with NOR. This is the SR latch which is constructed with NAND. So NOR and NAND, we are having a functioning table for this. Can you able to see this table from your S and R? If S is 1, R is 0. Then Q is 1, Q bar is 0. If both are 0, 0, Q is 1, Q bar is 0. After S is equal to 1, R is equal to 0. If it comes like that, then it will come like this. If it's 0, 1, then it will be coming like that 0, 1. So whatever this 0 0 is a previous state. For the previous state, whenever it goes off, whatever the previous output, that will be same. See here, in 1 0, it is set state. The set state, whatever it is there, if it goes to 0 0, also the same, remains same. Reset state, it remains same. In 1 1, it is called as a forbidden state it is. These are all the flip-flops. There are four types of flip-flops. SR, D flip-flop, JK flip-flop and T flip-flop. Flip-flop is a clock device it is, which is only clock device which is determines the new bit which is going to enter into the circuitry. It may be a positive as well as negative kind of clock pulses will be given as an edge. This is the diagram for SR latch. In this SR latch, see here, this latch is made up of NAND gate. This latch is made up of NOR gate. So there is a possibility to make a present state as well as next state. So that has been given it here. As a truth table. This is called as timing diagram. This is called as schema. Gated latch. In gated latch, we are going to enable the clock pulse also as a high one. This is the main difference between latch as well as gated latch. Clock is always high in gated latch. In D latch, yes or both the inputs are given as a single one, that is called as D. For D input, what is the output? Output is Q to the power of n plus 1. So D is 0, output is 0. D is 1, output is 1. It just carry out the task, it just store it and send it. So whenever enable button is not on, there is no change. Enable button is on, then it will be 1 and 1. If enable button is 1, data is 0, then Q is also 0. Q is nothing but output. If enable is 1, data is 1, Q is equal to 1. Right? This is the meaning of D latch. From similar kind of D flip-flop, we know another one that is called as T flip-flop. So flip-flop's characteristics are edge-triggered flip-flop, master state flip-flop, propagation delay time flip-flop. These are all the kind of flip-flops. Similarly, in J and K, there is only one difference in J and K from S and R. 0 0, there is no change because it is previous state. 0 1 is reset, 1 0 is set, 1 1 is normally in that case it is invalid. In JK it is toggle condition it is. So why? Because leading edge of the clock is going to produce it, not a falling edge. So in a asynchronous preset as well as clear inputs from the flip-flops. Preset and clear, these are all the two inputs which is going to make it as low preset and clear. Right? Without this, the task won't work because this flip-flop is affected by synchronous as well as asynchronous. Asynchronous means what? Independent of clock. Synchronous means clockwise it's going to affect. That is the meaning of flip-flops. In T flip-flop is for toggling. T flip-flop useful for constructing the counter circuits. Positive edge triggered flip-flop it is. In master-slave flip-flop, we can see both kind of latches will be there. One flip-flop is acting as master, another one is acting as slave. Right? In master and slave, set and reset are same. 0 0, there is no change. This is the master slave flip flop. Right? Master is isolate means slave is enabled. Master is enabled means slave is isolate. So this is the meaning of master and slave. Anyhow, for both the case, the clock pulse should be high, right? Thank you. This is the final flip-flop output we can get it. Thank you very much for your cooperation.